So heating value, let's go to heating values. So heating value, it is defined as, so that is the energy that is being released by the fuel when it is completely burned and the products of combustion are cooled to original fuel temperature. Now, we have two types of heating values. So we have your higher heating value and we have lower heating value. Now, for higher heating value is the heating value obtained when the water in the product is liquid. Okay. For lower heating value, LHB is the heating value obtained when the water in the product is in a form of vapor. Now for solid fuels heating value with the presence of fuels ultimate analysis, so we have the higher heating value of solid fuels, so that is equal to 33,820. So we have your C, which stands for your carbon, then plus 144,212. So multiply it by hydrogen minus your oxygen divided by 8, then plus 9,304 for your sulfur. So take note, the units will be kilojoule per kilogram. So we have the equation for that one. Now where your C, carbon and hydrogen and oxygen and our sulfur and in decimal form from the ultimate analysis. Now for coal and oils with the absence of ultimate analysis, we have this air fuel ratio, no? So that will be higher heating value divided by 3041. So this is by using the higher heating value to get the air fuel ratio. So we have here the units of kilogram of air and kilogram of fuel. Now for liquid fuels, the higher heating value is equal to 31,405 for the value multiplied by the carbon and 141,647 multiplied with your hydrogen with the unit of kilojoule per kilogram. And also it can be expressed your higher heating value in equal to 43,385 plus 93 times Bohm minus 10. Okay. So where Bohm is equal to degrees Bohm. Okay. So the unit is also kilojoule per kilogram. Now for gasoline, we have here your higher heating value is equal to 41,160. So plus 93 times the degree API. So we have your units of kilojoule per kilogram. Now for lower heating value is equal to 38,639 plus 93,000 times the degree API. So degree API stands for American Petroleum Institute. So that is used in terms of for expressing your types of your fuel for American Petroleum Institute. Now for kerosene, we have higher heating value that will be 41,943 plus 0.93 times the degree API. So that will be multiplied to the unit of with the unit of kilojoule per kilogram. For lower heating value, that will be 39,035 plus 93 times degree API. So again, we have your unit that will be kilojoule per kilogram. Now for fuel oils, we have your higher heating value that will be 41,130 plus 139.6, then multiplied to degree API. So the unit is kilojoule per kilogram pa rin. Then lower heating value, that will be 38,105 plus 139.6 times degree API, that will be kilojoule per kilogram. Okay, so again, API, so defined as American Petroleum Institute. And it is the degree API is used to classify the fuels. Then for fuel oils from Europe's standard formula, we have higher heating value that is equal to 51,706 minus 8,703.8. So we have here your sulfur. Okay, so that is raised to squared. So if sulfur is given, kilojoule per kilogram, lower heating value is equal to higher heating value minus the sensible heat. So that is also in the unit of kilojoule per kilogram. Now the sensible heat, that will be 2442.7 times 9 times your hydrogen. So the unit is kilojoule per kilogram. So we can substitute that one to get your lower heating or high heating, so we can transpose the to the equation on the other side. Now for the hydrogen value, we have 0.6, no? So that will be minus 0.15, no? Times the S will be kilogram of each hydrogen per kilogram of fuel. Sorry, this is not the sulfur. The value of this one is this specific gravity of fuel at different. This is a specific correction for that one. This is a specific gravity. Now Sg is equal to 141.5 divided 131.5 plus degree API. Okay, so where S at the given temperature, we have the correction, we have your S, specific gravity, that will be 0.007 times the given temperature minus 15.6. So this is a form of correction for the specific gravity of fuel oil. Has the following composition on mass basis. We have 82% hydrogen. Oh, sorry, this is carbon, which is 82%. Hydrogen is 8%, and we have sulfur, which is 2%. And you have your oxygen, which is 4%, and we have the value for your ash, which is 4%. Now in composition, on the mass basis for the carbon, so that is in terms now of percentage, so we have 0.82, hydrogen, that will be 0.08, and your sulfur, that will be 0.02, oxygen, that will be form of 0.04, and your ash, that will be 0.04. Okay, so let's write out the formula here for a higher heating value, no? So our equation for your higher heating value, that will be higher HHB, no? So that is equal to 33,820 times the carbon percentage, decimal in form of decimal, then plus 144,212. So we have your H2 minus O2 divided by 8, then plus 9,304 multiply by sulfur. So directly substitute lang natin yung values ng carbon in terms of decimal places. Okay, so let's do that. So higher heating value, that will be 33,820. So multiply by the value of C, that will be 0.82. Then we have 144,212. For our hydrogen, that will be 0.08. For your oxygen, that will be 0.04 divided by 8. Then plus 9,304. Then multiply by the value of your sulfur, that will be 0.02. Okay, so using our calculator, and we have the value of higher heating value for that type of coal. So that will be 38,734 point, this is 0.38. Okay, so the units is kilojoule per kilogram. So next sample problem, we have calculate the higher heating value of liquid fuel that is dodecane fuel. So the chemical formula for dodecane is C12H26. Now we have here the higher heating value for liquid fuel, so that is 31,405 multiplied by your carbon, okay, then plus 141,647 for your hydrogen multiplied by hydrogen, so the unit is also in kilojoule per kilogram. Now to get the percentage or volumetric percentage value of your carbon, so that will be the molecular weight of the carbon divided by the molecular weight of your fuel. Now to do the to substitute yung value, so for the percentage of your carbon, no, so we have percentage of your carbon, so that will, or volumetric, not a volumetric analysis, no, so we have the molecular weight of your carbon, so that will be 12, okay, times 12, so that will be 12 times 12, okay, we have that one, so divided by, so that will be divided by 12, no, for their molecular weight of your fuel, that will be 12 times 12 plus 26 times 1, so 1 times 26, okay. So using our calculator, so we have the value of percentage of your carbon, so that is we have 0.847 so that is equal to 84.7%. no Now for hydrogen, so we have the molecular weight of your hydrogen, so that will be divided by the molecular weight of your fuel, so this is equal to molecular weight of your hydrogen, that will be equal to 1 times your 26, then divided by the molecular weight of your fuel, so again the same also kanina, so we have your 12 times 12 plus 1 times 26, so we have the value for your hydrogen, which is equal to 0.529, or that will be 15.29%. Okay. Now substituting these values to our equation, so we have our higher heating value, so that will be 31,000 for this equation, 31,405 times the percentage of your carbon, or percent of your carbon in terms of decimals, that will be 0.847, no, plus 141,647. Now for your hydrogen, okay, so we have your hydrogen, so how much is your hydrogen? That will be 0.1529. okay, so using our calculator, we have our higher heating value of your liquid fuel is equal now to 48,257.86. So this is kilojoule per kilogram.